Okay, so yes, the cracking. So what is cracking? To break down something. So it is very easy to break something into two pieces. For example, if I give you a pencil or a wooden rod, so it is not easy to break it into 3 or 4 pieces, but yes, this is very easy to break it into 2 pieces. Same goes here. If they are giving you any hydrocarbon chain to break it for cracking, so that will be more easy for you to break it into 2 pieces. If you try to break it into 3 pieces, I mean, you can break it into 3 pieces. It's up to you, but the reaction will be difficult. Now, how can you take out three products from the chain of the hydrocarbon? So whenever there is a cracking reaction, just try to break it into 2 pieces. Simple. See. Um, Decane. Yes, we were doing about the decane. What is decane? Thin carbon. This is the decane. You can draw this decane on your notebook, so the reaction would be very easy for you. Decane means, I mean, there are 10 carbon and they all have hydrogen with them. If anyone is confused, so I can send you after the class the structure, or I mean the structure of this reaction. I can send you after the class. So you can draw decane with 10 carbon and 22 hydrogen. Okay. So after the reaction, I just told you, whenever you are cracking any alkane, you will get one alkene, which is ethene. So let's take out one ethene. Everyone knows what is the structure of ethene. This one. This is ethene. What is the formula? C. What is the formula? C2H4. What will be the other product? Some alkane. What alkane? You can see whatever is remaining in the chain. You can write it here. See, C10H22. We have already removed 2 carbon, means 8 carbon are left. We have already removed 4 hydrogen when we were making ethene. Ethene is something which is confirmed product. No? So we have already removed 4 hydrogen. There were 22 hydrogen. So 22 minus 4 will give you 18. Yes. So let's try to draw it. It should be alkane. So what do you have to do? You have to draw 8 carbon. 1. Okay, let me draw it for you. It should be alkane because we have already removed one alkene. So it should be alkane. Okay, so 1 carbon, 2 carbon, 3 carbon, 4, 5, 6. Okay, let me make it little vertical type. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons. And definitely every carbon will be making bond with the hydrogen. Okay, so let me mark with the blue one. 1 hydrogen, there should be 18 hydrogen. Okay, 2 hydrogen, 3 hydrogen, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. See, you got the reaction. This is so simple. This is the cracking. That's what I was saying. You don't have to learn the cracking reaction. What you have to do, you just have to remove one alkene, and for the alkane, whatever is remaining at the reactant side, you can make some structure with that remaining carbon and remaining hydrogen. You will get an alkane. So you don't have to learn the cracking reaction. Let me give you one more example. And this is the last example of cracking because we have to move to another topic then. 1, 2, 3, 4, 5. I mean, 5 carbon chain is also considered as the longest. The red one are the hydrogen bonds. Okay, what is the formula? C5. How many hydrogen are there? See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is the reactant. What is the name? Pentane. Penta means 5, and this is alkane because carbon is making single bond with another carbon. So this is pentane. Okay, so if I ask you to crack it, so what you have to remove? First, you have to remove alkene. Okay, you will get alkene. This is the confirmed product in the cracking. What we have removed? C2H4. Now what you have to do? You have to make some alkane. Now what will be the alkane? There were 5 carbon, so only 3 left. Because I have already removed 2 carbon when I was making ethene. And for the ethene, I have removed 4 hydrogens. So 12 minus 4 will give you 8. Let's try to draw it. It should be alkane. Okay. 3 carbon. 1, 2, 3. I'm making hydrogen bond with the red color. 1, 2, 3, 4, 5, 6, 7, 8. See. So there is no any difficulty in cracking now. There should not be any difficulty in cracking now. This is so easy. Uh, yes, any question or any confusion? So you can open your mic and ask me. Sabur, any confusion?
No, miss, I don't have any confusion. This is really easy.
Okay, so yes, Arina, if any confusion?
No, miss.
Okay. Okay, Hera, if you have any confusion, so you can open your mic and you can tell me. If you have any confusion, so I'll revise the thing. Otherwise, I'm sure this is really easy and I have already given you a trick. So I guess you will never forget about the cracking. I mean, you don't have to revise cracking now. Let's move to another thing. I have told you one thing here. For example, there is hydrocarbon which contain 2 carbon. If I'm adding more carbon here, so I mean the chain will be longer and the boiling point will be increased, the melting point will be increased, the force of attraction between the particles will increase. I mean, if force of attract, actually what is happening when I am adding more carbon in a chain? I mean, it was simple like this, ethane. I have added, like we just did with decay. There were 10 carbon in a chain. So if you're adding more carbon in a chain, so you are adding more particles. In simple words, we are making something denser. Denser means more particles. More particles, so they are coming close together, they will give you solid state. So the shorter carbon chain, all the compounds which have less number of carbon, they are gas at room temperature. As you are increasing number of carbon in a chain, the particles, I mean something will become more denser. You are adding more particles, so particles are coming more close together. When they are coming more close together, so they will I mean the compound will convert into the liquid. If you are adding more particles, more force of attraction, more density, so the compound will convert into the solid. So all the hydrocarbons which have a lot of carbon in a chain, they are solid at room temperature. And any hydrocarbon which has less carbon in a chain, so they are gaseous at room temperature. As you are increasing carbon and number of carbon in a chain, so state will become solid, force of attraction will increase, the density will increase, the melting and the boiling point will increase. Uh, let me check if I'm missing something. And everyone should know that alkanes can be used as a fuel. Alkane or alkene can be used as a fuel. Alkane or alkene can be used as a fuel. I mean, we can burn them. The easiest example is CH4. What is fuel? I mean, what is the definition of the fuel? There is a simple definition of the fuel. If someone asks you what is fuel, anything which can burn and give you energy. How can something burn with oxygen? So this is the simplest alkane, CH4. It is burning with the oxygen. You know, oxygen is something which can help in the burning. So if you want to burn something, so definitely you have to use oxygen. Okay. This is methane, CH4. It is burning with the oxygen. It is giving you carbon dioxide, water, and large amount of energy. And that will be heat energy actually, because there is something like burning reaction. The reaction is called combustion reaction. And this reaction is a proof. This reaction as a proof that you can use hydrocarbon as a fuel. Okay. Next one is, let me check if I'm missing something. This is the easiest reaction. So whenever they're, for example, they are giving you any hydrocarbon, for example, C10H22, the decane. And if they are saying that we are burning it, what will be the product? So you don't have to be confused. Whenever hydrocarbon burns with the oxygen, any hydrocarbon, any organic compound, when they burns with the oxygen, so the reaction is called combustion reaction. And the products of combustion reactions, the products are fixed. There will be carbon dioxide, there will be water, and there will be large amount of heat energy. What you have to do here, actually, you just have to balance the equation. So whenever any hydrocarbon and whenever any hydrocarbon or any organic compound burns with oxygen, it gives you carbon dioxide, water, and large amount of energy. Okay. Let me tell the next thing. Okay. Let's move to alkene now. Alkene means carbon-carbon single bond. Oh, sorry, carbon-carbon double bond. So I'm picking up the simplest alkene, which is ethene, most commonest alkene. Substitution cannot be done here. Substitution is impossible in alkene. Reason? What is substitution reaction? When all bonds are busy, so there will be substitution reaction, means when all bonds are busy, when, for example, if there is carbon and all the bonds of carbon are busy with hydrogen or something, and if you are trying to add something into this compound, so addition is not possible. So you have to do something like substitution. You have to remove hydrogen, then you can add something. But this is alkene. For example, we have hydrogen gas. I want to add hydrogen gas into the alkene. So there will not be any substitution reaction. Whenever, I mean, how will you add hydrogen? Definitely you have to provide some energy or something. Or in simple word, let's make it more simple. Like if I'm trying to add hydrogen, definitely I'll apply some pressure. I'll pressurize the things. And due to my pressure, the double bond will break. There is no substitution like something, no. When I try to add hydrogen gas into the alkene, so the double bond will break. As double bond will break, so both the carbon will be having one bond free. Hydrogen gas had two hydrogens, so one will be here and one will be here. So what happened here? Let me show you. Let's go to the product side. After adding hydrogen, so this was ethene, but due to pressurize this or something, the double bond has been broken down and both the carbon has one bond free, so you can add hydrogen here. This is called addition reaction. We have added hydrogen without removing anything. If you are adding hydrogen by removing anything, that is substitution reaction. You cannot remove anything here from the alkene when you are trying to add something. You don't have to remove anything because there is a double bond. When I'm trying to add hydrogen into the alkene, so the double bond will break and both the carbon will be having a one bond free. So you can add hydrogen over there and you will get alkane. The reaction is called addition reaction, but this is a special type of addition reaction which is called hydrogenation. Hydrogenation of alkene will give you alkane. And dehydrogenation of alkane means if you are removing hydrogen from the alkane, it will give you alkene again. So basically, hydrogenation of alkene will give you alkane. Dehydrogenation of alkene, dehydrogenation of alkane, this is alkane, so dehydrogenation of alkane will give you alkene back. Other than this, because we have to move to the alcohols now. For example, instead of hydrogen, if you have, for example, chlorine gas, or let's react it with HCl. HCl. This is HCl, hydrochloric acid. I am reacting ethene with the hydrochloric acid. There will be addition reaction, means the double bond will break. Reason? Double bond is double bond can be broken down. There will not be any substitution reaction. Whenever you try to add anything into the alkene, double bond will break. So both the carbon will be having single bond free. So HCl has hydrogen and the chlorine. So hydrogen here, Cl here, you will get chloroethane. This is called haloalkane. I mean, this is alkane. Now, carbon and carbon, they are having single bond between them. No? So this is called alkane. And chlorine is attached, haloalkane. And what I did here? Something like addition reaction. The type of addition reaction is called halogenation. Halogenation of alkene can give you haloalkane. Halogenation of ethene can give you haloethane. Halogenation of pentene can give you halopentane. This is so simple. Now, the alcohol ones. Okay. For example, instead of HCl, I'm bringing water molecule. So water contain hydrogen and oxygen, but water contain H plus ion and OH negative ion. Whenever you try to break water, it always break into hydrogen ion and the hydroxide ion. So again, when you try to add water molecule into the ethene, so the double bond will break and there will be two bonds. You can attach hydrogen here and OH here. So the reaction is called addition reaction, but the type of addition reaction is called hydration. Hydration. So hydration is a type of addition reaction. Simple. Hydration of alkene can give you hydration of alkene can give you alcohol. This is alcohol now, OH. OH is a functional group of alcohol. So hydration of alkene can give you alcohol, or you can say hydration of ethene can give you ethanol. There's a question in your topical past paper. Let me see the question. Yes. The reaction is for the hydration of octene. Octene is an alkene in which there are 8 carbon and there is some double bond between the carbon. Octene. Hydration of octene will give you octanol. Hydration of hexene will give you hexanol. Simple. Now this is alcohol. What is the importance of alcohol? We have discussed it in the bonding, I guess. This is the best solvent. I mean, water is considered as a universal solvent because that is not harmful, that is not flammable, that is easily available, not expensive, that is cheaply available. So water is considered as a universal solvent, but you all know that water is a polar compound, and being a polar compound, water can dissolve only polar things. Non-polar things cannot be dissolved into the water. Reason? The polar compounds can dissolve into the polar solvent. So water is a polar solvent, but this is ethanol. This is non-polar solvent, but this is polar solvent also. I mean, ethanol is something. It is very special solvent which can dissolve polar and non-polar both. Reason? This end is non-polar. This end is non-polar. We have discussed polarity in a previous class. When polarity arises, actually, polarity, I mean, there will be polarity when someone is holding electron. When element will hold electron, when it is more electronegative, when that is more powerful. I told you, I mean, I was using the word powerful, more nuclear charge. Basically, I'm discussing about the electron negativity, no? So between hydrogen and carbon, there is not that much electron negativity difference. Hydrogen is very light element, not electron, that is not electronegative. It has very less nuclear charge. It cannot hold electron. Carbon is also less electronegative. But you know, there are 3 most electronegative elements in the periodic table, and whenever they are present in a compound, so the compound could be polar, and they are nitrogen, oxygen, and the fluorine. Also the chlorine, I mean, the halogen group is considered as electronegative one, but if we discuss in a journal discussion, the nitrogen, oxygen, and fluorine are the most electronegative element. The fluorine is the super electronegative. The second number is for the oxygen. Oxygen is second most electronegative. And after the oxygen, there is nitrogen. So you can see there is oxygen in ethanol. And oxygen is more electronegative. It is trying to hold electron from the carbon. So partial negative charge would appear here. So at this end of the ethanol, there would be polarity. One end would be non-polar and one end could be polar. So when you are trying to dissolve the polar things into the ethanol, so this polar end will dissolve that polar thing, and this non-polar end, the left side one, will dissolve non-polar thing. So ethanol mean alcohol. The importance of alcohol is only one. Sorry, there are two importance of alcohol. Number one, they can dissolve polar and non-polar, both the things. And other thing is they can be used as a fuel sometime. They can burn with oxygen also. But there is one thing about the ethanol or the alcohols. Whenever you are working with the alcohol in the lab, for example, if you are working on the boiling point, so if you are checking the boiling point of water or anything, you can turn on the Bunsen burner, or you can heat the water up, and then you can check the temperature at which water boils. But if you are working on with the alcohol, or for example, if you want to know the boiling point of the alcohol, you cannot turn on the flame. Reason? Alcohol is flammable. This is highly flammable. So keep in your mind, whenever you are working with the alcohols in the lab, you don't have to use Bunsen burner. Instead, you have to use what is that called? Electric heater. So this is all about the alcohols. So alcohol, but let me tell you one thing. Let me draw the alcohol again. This is the alcohol, the simplest alcohol, which is ethanol. And let me remind you again, this is not hydrocarbon because it doesn't consist of hydrogen and carbon only. There is one oxygen, means this is organic compound. This is not hydrocarbon. Okay. Other than this, let me check if I'm missing something in alcohol. We have discussed about the formation of alcohol. Okay. Let me check if I'm missing any reaction. We have discussed all the basic reactions of alkane and alkene. Okay. We have different alcohols. The alcohol of methane, for example, if you are, let me show you. The alcohol of methane is methanol, simple. Alcohol of ethane will be ethanol. Alcohol of propane will be propanol. And same like butane, it will be butanol. Okay, and so on, pentanol, hexanol. Okay. Yes, methanol, ethanol, propanol, butanol. These are alcohols. All are flammable. All are flammable. But there is one thing. Methanol contain 1 carbon. Ethanol contain 2 carbon. Propanol contain 3 carbon. Butanol contain 4 carbon. You can see we are increasing the carbon chain. We are increasing the number of carbon in a chain. So what happened? The boiling point will increase. They have given you a question in your past paper that what is the difference between in a boiling point of ethanol and the butanol? So the simple answer, you don't have to learn the boiling and the melting point. No, simple. Butanol has more boiling and melting point as compared to ethanol because butanol has more number of carbon in a chain. This is a simple answer. Okay, other than this, formation of ethanol. Okay, there is a question in your past paper. Give 2 reactions by which we can make ethanol. 2 reactions. We just discussed one reaction. For example, if you have ethene, so you can do some addition reaction with the water. You can add water, you will get ethanol. We just discussed this reaction. This is called hydration of ethene or addition reaction of ethene. I mean, we are adding water into the ethene, it will give you ethanol. But they are asking you for 2 reactions by which you can make ethanol. अच्छा बनाना भी ethanol ही है हमें. Oh yes, fermentation. Fermentation, for example, if you have glucose, C6H12O6, definitely there will be some enzymes in yeast will be involved, and they will give you ethanol, C2H5OH, and the carbon dioxide and large amount of energy, definitely. This is another reaction of for the formation of ethanol, because they are asking you to make ethanol by two methods. So the first method, you can say hydration of ethene is a chemical method to make alcohol, and fermentation is a biological method to make alcohol. But this is your chemistry question. If I mean, the reaction is called fermentation. Okay. And yeast will be used as a catalyst here. It means you have to add yeast in a glucose, because there are some enzymes in a yeast, and those enzymes will try to convert glucose into ethanol and carbon dioxide and little amount of energy. Okay, there is one more reaction of alcohol. I'm giving you the simplest reaction. Definitely all the reactions will be the same. They may ask you about the combustion reactions of the alcohol also. For example, let's pick up the ethanol. What is ethanol? This is ethanol. OH, and all the empty bonds are filled with the hydrogen. These red one. Okay, so this is ethanol. So what will be the combustion reaction of ethanol? We just discussed all the hydrocarbon or the organic compound. On combustion, they will give you carbon dioxide, water, and the heat energy. React it with oxygen gas. You don't have to be worried that what will be the product. No, this is organic compound. Every organic compound or hydrocarbon will burn with the oxygen. It will give you carbon dioxide and the water molecule and some heat energy. All you have to do here is to balance the equation. Let me balance it for you. It was 3 3 something. You have to write 3 here, you have to write 3 here, you have to write 2 here. You can practice to balance this equation. So the combustion reaction of organic compounds or the hydrocarbon is very easy, but you should know how to balance the equation. Other than this, how, wait, from ethene to ethanol, and from ethanol to carboxylic acid. Okay, let's make some ethanol. This is ethanol. If you want to convert this ethanol into ethanoic acid, what you have to do? Simple. You have to do some oxidation of ethanol. I mean, you don't have to react with oxygen gas. You have to do something like oxidation. Oxidation means adding of oxygen, not oxygen gas. Combustion means, I mean, if you are reacting alcohol with the oxygen gas, means you are doing combustion reaction. You will get carbon dioxide and water and energy. But if you're doing oxidation reaction, you will get ethanoic acid. There is a difference between oxidation and combustion reaction. We have combustion reaction in which you have to use oxygen gas, the diatomic oxygen, O2, which will burn the organic compound in the hydrocarbon and will give you a lot of energy also, because the heat energy, because it is burning the hydrocarbon or the organic compound. Combustion reaction means you are reacting ethanol with the oxygen gas. Oxidation reaction means you are adding oxygen. What is the definition of oxidation reduction? If you remember from the IGCSE or O levels, oxidation means gaining of oxygen, not gaining of oxygen gas. No one can gain oxygen gas. For example, if there is a compound and that is reacting with oxygen gas, it will burn with the oxygen. So basically, there is a difference between oxidation reaction and the combustion reaction of alcohol. Both the reactions are there in your past paper. And there's a question in your past paper, they may ask you, what is the difference between oxidation reaction or the combustion reaction of the alcohol. And I have seen many students say the same. I mean, there are a lot of students and who say, and all say that oxidation and the combustion reaction both are the same thing. No, oxidation reaction means you are adding oxygen into the compound. Combustion reaction means you are burning something with the oxygen gas. In combustion, you have diatomic oxygen. In what is this? In oxidation reaction, you are using monoatomic oxygen. Monoatomic oxygen, and you will get ethanoic acid. You don't have to work on the reaction. Whatever I'm drawing on the screen, you just have to do this thing. You have ethanol, you are doing some oxidation, you will get, oh, carbon, this one. This is carboxylic acid. You don't have to learn the reaction. If they ask you, how will you make carboxylic acid? Simple. You should know the journal reaction. What is the journal reaction? Alcohol, the oxidation of alcohol will give you carboxylic acid. The oxidation of ethanol will give you ethanoic acid. The oxidation of hexanol can give you hexanoic acid. This is so simple. Let me check some questions. Yes, they are asking you to write the reaction of oxidation of heptanol, hepta means 7 carbon. So heptanol, you have to make 7 carbon, you have to attach 1 OH with the 7 carbon, and you have to write this oxidation is something, and you will get heptanoic acid. This is so simple. Octanol, octanoic acid. You just have to add 1 oxygen. This is so simple. So what is the journal reaction? The journal reaction is, if you have alcohol, so if you are reacting alcohol with the oxygen gas, you will get carbon dioxide, water, and the energy, and the reaction is combustion reaction. If you are reacting, if you are adding monoatomic oxygen, or if you are adding oxygen atom into the alcohol, the reaction is called oxidation reaction, and you will get carboxylic acid. From ethanol, ethanoic acid. Heptanol, heptanoic acid. This is so simple. Let me check if I'm missing anything here. Okay, yes. Anyone is having any confusion? Now there are 3 students. Yes. If any confusion now?
No, miss, no confusion.
Okay, Hera, do you have any confusion?
No, ma'am.
Okay, Sabur, do you have any question?
No, miss, I don't have any questions.
Okay, let's move then. So this is all about the alcohol. Let me check the topical ones. Oxidation and the combustion. Okay, I have discussed all the things. I have told you that if they are giving you octanol, I mean the alcohol of the octane, I mean they will give you like this, there will be 8 carbon and there will be some OH. You just have to add oxygen and you just have to do something with the last carbon like this, carbon, double bond oxygen and OH like this. So octanol to octanoic acid, this is so simple. Let's move. Okay, one thing, we just made carboxylic acid. Let's pick up the simplest carboxylic acid. This is the simplest carboxylic acid, the carboxylic acid of the ethane. From ethanol to, oh, there will not be any hydrogen. From ethanol to ethanoic acid. Okay. I'm calling it acid, carboxylic acid. It means it can help in neutralization reactions, because every acid can neutralize the base, every acid can neutralize the alkali. So one thing more, I guess we have already discussed in different classes that organic acids are considered as a weak acid. Okay. This is carboxylic acid. So it means it should react with the base. It should perform or it should participate in a neutralization reaction. I mean, we just want to discuss the proof that this is an acid. Is it really acid? Okay, let's try to react it with the base. It should give us salt and the water. Okay, you can pick up this is the ethanoic acid, the carboxylic acid of the ethane. You can pick any base. Let's pick up the simplest base, the most common is like NaOH. Let's pick up the alkali, NaOH. This is the most common. Okay. The reaction will be a little tricky. Wait. NaOH, Na positive, OH negative. What will happen? Let me circle with the green color. See, this is Na positive. Okay, wait, let me make it more easy for you. Let's consider this one. Let's focus on OH negative. This is OH negative. What we have to do? A neutralization reaction. What is the product of neutralization reaction? There are two products normally there are two products like salt and the water. So this is OH negative. Let's make it water. We can remove this hydrogen. I'm circling with the green one. And you can make water at the product side. Okay, see what is remaining here. Double bond oxygen is as it is here. You don't have to learn the reaction. You just have to know that how to make structures. And what is remaining? I have removed one oxygen.